Hi again, Year 9. I'm going to talk through the page on standard form, which is page 19 of the number 1H pack. Now, standard form is a method of writing very large or very small numbers. We need this because if we were dealing with something, for example, like massive distances from the Earth to the Sun or something in meters, that would be a lot of digits to type into a calculator if we needed to do any calculations on that. It would be very easy to miss out a 0 or something like that. Also, very small numbers, like the mass of an electron or something you might need to use when you're doing your A-levels or further studies. And that's obviously very, very, very small. 0.000, many zeros, and then some numbers. And very easy to miss out some zeros. It's also quite restrictive because some calculators won't enable you to type in very long numbers on your calculator. So we need another way of writing things. And what this relies on is powers of 10. If you think about our powers of 10, given the pages we've just done, powers of 10 get very big very quickly. So 10 squared is 100, 10 cubed is 1,000, and so on. And every time we add a 1 to the power, we add a 0. And that enables us to use these powers of 10 to write big numbers like these ones. So this number here, 40,000, not an enormous number, but it's a good one to sort of introduce us to what standard form is and how we can use it. Now the rules of standard form are that it should look like this. Some multiplier times 10 to the power of something else as a power. Okay, so the rules are that this multiplier needs to be between 1 and 10. So between 1 and 10. Now it can be 1, but it can't be 10. It has to be less than 10. It has to be a single digit, in other words. It has to have some units, but that's it. Nothing more than just units. The power can be absolutely anything. It can be positive or negative. Okay? So I'm just going to put A there. Right, for this one, what number would we use to represent, what digit would we use to represent this number that's between 1 and 10? Well, it would be 4. That's the best one to use. It's the only digit that occurs in the number. And the way I remember what the power should be is to think about how many times I need to move the decimal point from where it is now, which is at the end of the number, to where I want it, which is after the 4. So if I move it once, twice, 3 times, 4 times, it ends up where I want it to be. So this is 4 times 10 to the power of 4. On B, the digit I'm going to use is 2, and I need to move the decimal point. Oops, zoom in a bit. 1, 2, 3, 4, 5, 6 times. 2 times 10 to the power of 6. Part C is going to be 8 times 10 to the power of 6. Okay, and you get quicker at doing this the more you do. D will be 7 times 10 to the power of 3. And the more of these you do, the more you sort of spot shortcuts and things. I mean, so far we've had single digits, and the power next to the 10 has been the number of zeros. Just be careful applying that rule to all of them. It will only work for some of them. This one will be 1 times 10 to the power of 3, 6, 7, 8. 900 is 9 times 10 to the power of 2. And if you think about 10 to the power of 2, that is 100. So 9 times 100 is 900. Now, this is the first one with a couple of digits, rather than just one digit. So the number I'm going to use between 1 and 10 to represent this is 2.5. So that's how we do this. We just move the decimal point. Now, how many times have I had to move it from where it is now to get it between the 2 and the 5? 1, 2, 3, 4, 5. And that's why I say, with caution, don't just make the number of zeros this power here, because in this case I've only got 4 zeros, yet my power is 5. Okay. On the next one, between 1 and 10, I'm going to go for 1.9, times 10 to the power of 1, 2, 3. This is how many times I need to move it to get it between the 1 and the 9. This one is going to be 5.4 times 10 to the power of 3, 6, 7. This one is going to be 1.1 times 10 to the power of 3, 6, 7 again. 8.9 times 10 to the power of 4. And the final one, 3.6 times 10 to the power of 3, 6, 9. Okay, and this is the sort of number that we're getting towards that we would actually need standard form to represent. Okay. Question 2, we're doing the reverse. We're writing numbers that are in standard form as ordinary numbers. So you've seen how to do it the other way around. Here's how I would convert back to an ordinary number. I would first write out the digit that I'm given, and then I would move the decimal point from where it is now 4 times. 1, 2, 3, 4, and I need to include that many zeros, okay, to fill the gaps. So there we go, 30,000 is that number. For part B, 9 is my number. Decimal point would normally go straight after that. I'm going to move it 3 times though, because the power is 3. 1, 2, 3, so that's 3 zeros I need to add in. So 9,000. 6. And then I would move the decimal point 6 times. So I'm going to add in 6 zeros. 2 times 10 to the power of 10, so that's going to be a 2 with 10 zeros. If you remember, numbers should be in groups of 3, so might make it easier to say these numbers if we group our zeros where we can. Okay, so that number would be 20 billion. E would be 50 million. So 5 with 7 zeros after it. Now when we get to question F, I'm not just going to add 2 zeros. I'll show you why. If I put 1.2 and then I put my pencil on the decimal point, because it's no longer going to be a decimal point, I'm going to move it once, twice, so it's going to be there now, the decimal point. I only need to add in 1 zero because the 2 was already taking up one of those spaces, so the number is 120. 2.9, and then I need to move the decimal point 5 times. 1, 2, 3, 4, 5. So this number will be 290,000. Okay, and I will do the rest while the video is paused. Okay, there's the answers to question 2.